Hi guys, welcome back. We're just about to kick off our Adding Azure Web Services session here. I'm Jason DeBoover. I'm going to be your host while we go through this next hour and look at how we can integrate Azure mobile apps into our application. The general idea here is that we have a great working application given to us by my previous instructors, Jesse, Renee, and Rob. However, that application is completely offline. That means I can't really update those questions without completely delivering a new application to the App Store and then hoping that the users actually download that update. Instead, I want to be able to integrate with a web service, pull those questions dynamically. Additionally, we're even going to look at how we can do this in an offline supported way, meaning when we're online, I can pull updates. When we go offline, no problem, I'll just refer to my offline updated database. All right, let's get started, but before we do, I want to remind you guys that we are being brought to you today by Xamarin University. It's where I work, it's where all the instructors that you're seeing today work. We've got hundreds and hundreds of hours of in-depth mobile development advice. We've got material to get you certified as a mobile development expert. We've got self-guided learning that's actually available absolutely free and is soon to include our Azure materials. We've also got the ability to do one-on-one counseling with you if you need a little bit more customized help. So please check it out and we'll get you to be a mobile development expert. So let's jump in to developing our mobile app service. First of all, what we can do with a mobile app service is integrate with a lot of the other services that Azure provides. The mobile app provides an endpoint for us to access things like our SQL tables. That's what we'll be doing today. Table storage if you want, blob storage, MongoDB. We can also integrate with authentication from our own Active Directory or from Facebook, Google, Twitter, really any OAuth provider. And we can also use our Azure mobile services as kind of our hub for notification services. All right, all this is done through REST, and then we don't really need to mess with any kind of HTTP client or anything like that ourselves because most of that then is handled by the Azure SDK. So Azure actually has, as we can see here, a client library, which is what our client applications will utilize. Those under the surface use things like HTTP client, but we don't really concern ourselves with that most of the time. In fact, there are actually client SDKs for not just Xamarin and not just .NET, but there's Objective-C client libraries, there are Java client libraries, JavaScript client libraries. Of course, we hope that you're using the .NET client libraries running on Xamarin, but that's not a requirement. So our back-end service, of course, can be implemented in .NET, and we'll talk about that in just a second, but also it can be implemented using Node.js. Now, Node.js provides us a really, really quick and easy way to do things. It does code generation directly from the portal, so we can mostly just do point and click to get a backend service up and running instantly. That's actually what we're going to do today to make things happen fast. Now, even though it's code generation, even though it's point and click to create, it's still code. That means we can still go in and actually customize it. It's still code, it's just initially generated for us. Now, of course, the other option is ASP.NET. Now, when we do things with ASP.NET, we're going to create it in Visual Studio. We're going to have an incredibly robust environment with all the type checking and all the libraries of .NET that we're used to. So let's jump right in to creating our first application. Here is my Azure mobile portal. I'm just going to go up here and hit New. Of course, give it a second. We are actually working with a remote website right now. And I'll go down to Mobile and find my mobile app right here. Click that. And we're going to have to give this a name. We'll call it VS Connect Exam Live Demo. And I am going to use an existing resource group. For more information on resource groups and app service plans, you can check out Xamarin University's Azure track. We have an Azure 101 that talks all about that stuff. And I will go ahead and hit create. So now I'm going to go find my app services here. And here is my live demo service. You can see I had a practice round. And here we go. So we can see there's my URL. Already have a URL up and running. It goes to vsconnect live demo .azurewebsite.net. Hey, successfully created. If I browse in here a little bit, I'll be able to see some pretty cool stuff. Now, of course, there's a lot of things we can set up, a ton. We can set up SSLs, we can have our own custom domains, we can do deployment slots, so we have zero downtime deployments, all sorts of options. We don't have time for all of it today, but there is a few really important things I do want to jump in and show you. So first of all, let's scroll down a little bit until we find our easy tables. That's where we're going to start adding our database connections at. Okay, but first, before we actually get into doing that, I want to scroll down a little bit more and find our debug section. Development tools section. It was actually not scrolled down, it was scrolled up. And here we have a couple interesting things, actually several interesting things, but a few that I'm going to zoom in on. So my advanced tools here is going to take us to the Kudu dashboard or Kudu console. This is going to show us all sorts of interesting stuff about our environment. Kudu is actually not just a console for showing interesting things like our environment variables, okay, and our app settings, our connection strings, etc. Right? It can do all this, can show us our process. But the reason it's doing all this, the reason it needs APIs into all this is it's actually part of our continuous integration environment, right? Kudu is actually there to help us auto-compile, say, our C# code. If we do a check-in to get and we want it auto-deployed, it has to actually compile, right? So Kudu is there doing that stuff for us. Of course, to manage that and to get everything done live in real time for us, it needs to know a lot about our environment. And then it goes ahead and provides us this window through this portal right here. So there's a lot of interesting things we can get for debugging and for just kind of learning about the environment that our app is running in when it's deployed to Azure. Okay, the other really interesting thing we're going to want to know about here that we have access to is going to be our live editor. So this is basically an IDE right here in a window, available to us in Edge or whatever other browser you're using. Once again, it's that website load up time. Just give it a second. Okay, as we can see, by default, even though I selected a mobile app, I don't have a lot going on here yet. Once I start doing some of that point and click business we talked about, that's going to start auto-generating some very, very interesting stuff. And we'll be able to see that even though we point and clicked to create it, and even though it auto-generates the files, once those JavaScript, those Node.js files are created, we get to be able to go in, tweak things, change it, modify it, customize it. And we can actually do it right through here. Of course, we also have FTP access to our entire directory, and we can tweak things through our regular IDEs if we prefer as well. We can tweak things right through Visual Studio or VS Code if we wanted to, but having access right here is pretty great. So now let's jump back in to my slide deck. Now the next thing we'll talk about is adding a database to our Azure mobile app, to our back end. Now of course we're going to want a SQL database in our case, but that's not the only choice. We already know there are a few other choices. We have things like table storage, etc. But a SQL database is our Swiss Army knife. It can pretty much do anything. Now we're going to expose that through an OData endpoint. This is actually something that is point and click for us. It'll generate the necessary Node.js files for us to automatically have a REST endpoint that will access our table, including support for having special query strings in our URL that will actually do filtering and ordering, etc. And this is all standards based. We can, of course, change our database, modify our database, etc., all through our portal. And we'll look at a few different ways that we can actually do that. And then, of course, we can also, as I mentioned, add our own custom logic. Even though we're using some code generation with point and click in the portal, it is still code. It's JavaScript code, but it's still code. We can still go in and modify that ourselves. Now, when we create a table, we're going to do it through the portal. It's going to create both the necessary Node.js files for us to access it through OData, as we discussed. It'll also actually create the tables on the database once we've associated the database to our Azure mobile app. And when we create these tables, we're using a technology called Easy Table that does things for us. Obviously, it's point and click. It's going to also create a few columns in those tables. These columns are generally good to have best practice type columns, but they really become important when we start looking at the offline syncs type stuff, right? When we want to make sure that we can synchronize our offline database with the database that actually is in Azure. We can create our easy tables either through the Azure portal with the point and click that I've been talking about, or we can actually upload JSON configuration files that define a table. To do that, we'll be able to do it well through an IDE that's also built right into our Azure portal. Or we could connect via FTP and just start putting the configurations into this tables folder that's part of our WW root. Now, when we use the point and click on the web portal to create the tables for us, it turns out that it's doing the same thing. It's actually generating those JSON configuration files and putting them in the tables for us. Well, JSON and JavaScript both. And it's putting those in the tables directory for us. And then it's when our mobile app starts up that we'll actually read those tables files and then modify the database on our behalf. Once we have tables, we can populate some of the data. We can populate sample or seed data into our tables using CSV. There's an interface right in the portal to do that. Now, strangely enough, we must actually have a terminating carriage return line feed. So in other words, an extra blank line at the end of each of our files. That's probably an oversight. I doubt they actually intended to require us to do that, but that is the way it is right now. So let's go in and actually start creating our tables on our Azure mobile app. And we'll get started here. It's going to tell us that it doesn't have any data connections, that it's not configured, etc. And we're going to go ahead and help it out. Let's add a data connection. All right, so we're going to want to connect to a SQL database. Now, I have pre-baked a SQL database for you, but it's not too baked. That is, it's a completely empty SQL database. It's basically just point and click, new SQL database. It's just that it takes 3 or 4 minutes typically for it to actually have Azure to create it. I just didn't want us to wait staring at the screen while that happened during this quick demo. So it's already created. We just need to connect to it. But again, no magic back there, no sneaky business. It's just a completely empty database. It actually needs to load right there. That's what we're waiting on here. There we go. We want the live demo database. And I need to give it credentials. And hit OK. And hit OK. And now we'll wait for that thing to actually get created. Should not take too terribly long. Hey, there we go. We're created. So now we will actually have to open this blade up again. It actually kind of didn't do the right thing. It took us back to this screen right here. This is actually not correct. So we actually need to get it to show us. All right, here, let me close this window here. It kind of jumped us back to the wrong spot. That's okay. Go back and click on Easy Tables again. And then it will tell us that we need to keep setting it up. See, there we go. Now it knows that we need to keep setting it up. Okay, so now we're going to say, yes, we're going to overwrite. We already have a data connection. We're going to overwrite our existing site. So remember, it's doing some code generation for us, but if it's going to do code generation for us, we kind of have to accept that it can't magically merge that with other custom code that we've already created. So when accepting code generation, we're also accepting that it's going to overwrite our existing site contents, as well as go ahead and be able to add tables to the database we're pointing it at here, right? So initialize app, we'll have to wait a few seconds here again. All right, while we're doing that, actually, what I'm going to do is take us back over here to our, let me just reopen this actually, so we can see it properly, to our advanced editor. This is our IDE editor. And we can actually watch it creating those code, doing that code generation for us. So let's actually open this back up. And now we can see it's no longer just that welcome HTML page or whatever. We've actually got some stuff going on in here. Importantly, including our app.js file. And here we can actually see that the Node.js websites or web apps on Azure are based on the Express Node.js framework, which is a common and easily available framework, a framework with lots of extensions out there in the world. So we can easily upgrade this, customize it, do whatever we want to do with it. Of course, one of the things it also does is import some custom Azure code so that it works elegantly and nicely on Azure. And it includes this tables directory. So it wants to import things from the tables directory, which right now is empty. But as you guys are probably guessing by now, that's where our tables are going to end up. The code generation for our tables is going to happen after we start loading those up. So since I see a lot of this code has now been created, let's actually see if it tells us we're done over here. Go to Easy Tables again and see what this has to say. Okay, so it looks like we're ready to go. What I'm going to do now, go up to Add, and I'm going to start adding a table definition in here. We could also use this add from CSV right here, upload a CSV. Right now, we're not going to do that. We're just going to go ahead and add a quiz question table manually, and then we'll upload the data from our IDE. So I'm going to want everything at basically the default permission set, because we haven't really set up authorization, right? That's something we could do, but right now we're just doing a very basic demo here. So our table is created now, and now we'll go into manage schema on this, and we'll add our columns. Notice those required columns, those mandatory columns, are just created for us. They're already there. So let's manage our schema and then add the columns that we want to add in. I need a question. That's going to be a string. I need an answer. That will be a Boolean. Notice we have some limited data types. It's not like we have all of the data types available to SQL Server here. Even though this is real-time editing our SQL Server schema, we have some limitations involved. We also have an explanation for our answer, so that's also going to be a string. All right, super. So we've got everything in place now. We've got the columns that we want. Of course, we don't have any data yet, but we're going to take care of that when we move over to the IDE. All right, so now that we have a working Azure mobile web app, we need to actually connect to it. So as a reminder, we're going to be using our client SDK. This is something we're going to install through NuGet, although if you're using other platforms like doing iOS directly with Objective-C or Android directly with Java, there are other ways to install the Azure SDK for those as well. There's a SDK client library available for a vast array of client types, not just Xamarin clients. Of course, we're Xamarin. We're going to be using the Xamarin SDK or the Xamarin client library and installing it through NuGet. So that client library then is going to handle those REST calls for us. right? It's going to handle that HTTP stuff right here for us. We're just going to be making API calls right here, right? We're just going to be making method calls right here. Then it will turn it into the HTTP necessary to go over the wire for us. And then access, of course, those data tables. So we'll add the NuGet. We'll initialize the library. There'll be a couple steps necessary for initializing our library. So we'll look at those when we actually jump into the code. And then we'll start, of course, using our mobile service client object to go back and forth over the wire to our Azure endpoint. So once we know where we're going, of course, that's going to be our Azure website that we've just been working on. We'll create a mobile service client instance that points to it. Then we'll want to say service.getTable. We're going to call that getTable method. We've got a couple options here. This particular option is just going to grab a dynamic variable, which we can then start to look for our particular properties on. If we know what properties, what columns were on our table, we can, for instance, say, oh, we know ID is there. We can look for it. Of course, that's not using any kind of strong typing. So I can, of course, then instead point at my DTO, which in our case is going to be our quiz question, right? And so we can actually have it's deserialized directly to instances of our quiz question using our generic getTable method. And then it'll actually automatically assume the path involved. So it's going to go to our website /tables/ in our case, quiz question. There are ways to change the path if it doesn't actually perfectly match, but of course it's easiest when it does. Now, the operations that are going to happen, we're going to have methods available to us that correspond pretty well with what we'd expect when dealing directly with a table endpoint. So this is where OData comes in, right? The specification defines exactly what the HTTP request over the wire is going to look like. But we're going to make method calls like update async, insert async. Those are going to go over the wire to paths like so, with the appropriate arguments in place, the appropriate data. And then that's going to get translated by those OData scripts to insert statements on the SQL side, update sequence statements on the SQL side, selects, etc. Now, inserting, updating, pretty straightforward. Even deleting, pretty straightforward. We're going to grab that table instance from getTable, and we're going to call insert async. We're going to call delete or update async. These are pretty straightforward. Querying, however, gets a little bit interesting. So with our querying, we're actually going to be able to start to construct a link query. This will actually work somewhat like iQueryable, where as we're building up this metadata of what we want to query, we're not actually querying yet. When I first say create query, when I then say order by, when I then say then by, all I'm really doing is building up an object that has the metadata of what I want to query, what I want to filter, how I want to order it. And then only when I actually call a method that's going to, a toCollection method, maybe toEnumerable in this case that we're looking at, that's when it says, oh, okay, I need actual instances of these objects now. I can no longer keep just building metadata. I actually need to get an enumerable, need to get a list, etc. Right? So that's where it will then actually go over the wire and execute our query. And this is where, again, that OData standard comes in. So notice that it's going to tables / our table name, and then all of this is handled for us. Now, so far, everything we've done will work great and will allow us to pull data from Azure, pull those questions from Azure, and of course, then we can do updates to our server, and our customers that are using this app will get those updates because it's pulling real time. That's all great, but if those customers using those apps with their mobile devices fall offline, if they lose a connection, well, now they're completely inoperable. Right now we can't do anything with their apps. So let's fix that. We want to make it now so that when they're connected, they'll download updates. They'll connect to Azure and download the latest and greatest. When they're offline, however, they can turn to their local data store. Now what this means is we're going to need another NuGet package. So we'll get the SQLite Store NuGet package, which is also part of our Microsoft Azure mobile client spectrum, our client library there. So we'll add that NuGet package. And that then will mean we can have a SQLite database on each of our mobile devices, or a SQLite database as part of our mobile app. And then our Azure library can update our local copy anytime it's connected to the internet over, of course, the regular REST APIs. But when we're not connected, when that app's not connected, it will just turn to its own local copy. Even better, it works for inserts and updates as well. If we're not connected, we can insert to the local database. In fact, we always insert to the local database. And then when we are connected, it'll manage to sync it right up to the cloud, right up to our main Azure database. So the way we're going to have to do this is to add a few extra calls. We're going to initialize our SQLite database. We're going to initialize our SQLite, and in addition, we will no longer get table. Instead, we'll get sync table. And then, as you can see, we'll have to explicitly push our updates. So our sync table will actually represent our local table. And so when we want to take that and synchronize to Azure, we'll call sync context.pushAsync. You'll notice that this is global. This one applies to all of our tables. But then we can pull on an individual table basis. So we can say this table, diary table, or quiz question table, dot pull async. All right, and then we'll be ready to have complete offline capabilities, both update and read offline capabilities. So let's go actually jump into the code now and do all the things we've been talking about. The first thing we'll need to do is to get our NuGet packages in place. As it happens, I have already installed the NuGet packages for our project here. Otherwise, this is exactly the project that Jesse left us. All right, but I have gone through and installed those just in case they took a little time. But you can go to your solution, right click on your solution, manage NuGet packages, and then we browse. And what we'll be browsing for is our Microsoft Azure mobile client. Let me just click that there. And we'll see we have two options. And actually, if you just install the SQLite Store one, this actually has as a prerequisite the above one. So by grabbing this one, selecting all projects and install, it'll actually install both of them on all of our projects. Now I've already installed, that's why my install button is disabled. With that done, the next step is to initialize our Azure client. So I'm actually going to have to go through each project and do this. So main activity in my Droid project. Here, I will go through and right after my Xamarin Forms in it, I will say Microsoft dot Windows Azure. Come on. ID is a little confused at the moment. There we go. Mobile services dot current platform dot init. And then I also need to initialize SQLite. So SQLite PCL dot batteries dot init. I'm going to copy this because the code is exactly the same for iOS. So on iOS, I'm going to, my IDE is once again getting a little confused. On iOS, I'm going to go to my app delegate and again put it right there. We didn't get that copy. Let's go back, make sure it copied. We'll just do the old right-click copy this time. There we go. Okay, so now we're initializing our Azure client on iOS and Android. Things are slightly different on Windows. So we're going to focus on the universal Windows app and not have to go through all the projects here. On Windows, let me go ahead and open up my main page XAML CS. All right, and here, again, right before load application, I'm going to want to initialize my SQLite, but I don't actually need to initialize the Azure Mobile Services. Just not necessary on Windows, happens automatically. So only need the SQLite in it. Now, Windows does have some extra steps required though. So Windows does not include SQLite out of the box, unlike iOS and Android. So our packages are going to have to actually install that. In order to allow that to happen, first of all, we actually need to install an extension into our IDE, into Visual Studio. So tools, extensions, and updates. And if you just look online for my SQLite, you will actually see SQLite for Universal Windows Platform right there. Okay, so you'll go ahead and install that, or 8.1 or 8.0, depending on what you're looking for. And once that's done, now we need to go into our references. All right, so there's, like I said, a few extra steps here. So in our references, go to Add Reference. Go down to the Windows section, whether it's Universal Windows or Windows 8.1 or whatever. Go down to that section, hit Extensions, and then we're going to go looking for the C++ runtime. All right, hit OK. And that now will allow us to run on Universal Windows. All right. So with all that craziness in place, just that infrastructure stuff, now we can start looking towards actual code. All right. Let's now look at the code that Jesse gave us. Looking over in my portable, my app.cs is where I'm loading up my questions. All right, my app.cs, I'm loading up my questions from that JSON file, right? Now, I want to actually change this a little bit because we don't want to use the JSON file necessarily. We want to use Azure. We want to download from Azure. So just as a kickoff point here, let me start by just commenting out what we've got there. All right, I'm going to comment out the stuff so far that's getting us our questions. All right, we'll go, there we are. And instead, we're going to be getting them from Azure. Now to do that, I'm going to need some class that knows how to talk to Azure. And well, we are at a time crunch here, so I'm going to go ahead and copy and paste a little code, but I'll explain it all to you. All right, so we're going to add new item here. And I'll add a class. Now this class is going to be my Azure service. And as soon as that's in place, we're going to do the old copy and paste, voila. Here we go. All right. So now I'm going to just, as I said, copy and paste. Whoops, I didn't copy and paste adequately. There we go. Now we've got that in place. So let's check out what I actually added. Now, first of all, if we were going to use the dependency service, this would allow us to do that. We're actually not going to do that today, so we'll overlook that. We're already talking about the dependency service elsewhere in this app. Now, down here, we see that I have this initialize method in my Azure service. All right, and we can see that what we're doing is we've got a mobile service client. We want to see, does that exist? If so, does it have a sync context? If so, is that sync context initialized? And if it's initialized, we have nothing left to do because this is an initialize method, so we return. However, if it's not, or if those things don't yet exist, we can start putting them together. All right, now we grab our Azure URL. That's not exactly correct at the moment, is it? So we're going to have to actually correct that, get the right URL in place. And then let's go down. I will do that in just a second. We create the instance of mobile service client that we were referencing up there. All right, we'll create that instance pointing at our Azure database, our Azure mobile service, I should say. Now, because we're going for offline sync mode, we'll also need to initialize a local database. So we pointed at QuestionsDB, and then we're going to go ahead and find the default path for this, and then create our SQLite store. By the way, SQLite isn't the only way that you can do offline storage with Azure, but it is the default. All right, so we're using the SQLite store to do this and pointing at the path that'll create our questions DB, make sure our table exists, and then we're going to initialize our sync context. Because remember, we want to synchronize, we want to have offline sync. So that's exactly what we're doing. Our store is referenced right here. We make sure everything is wired up together. And the sync context is kind of the traffic controller for the whole synchronization thing. And then we say get sync table. Remember, this is instead of get table, we're getting sync table. Now, down here, we end up with a get questions method. Notice this one's public. And so this is actually what we're going to be calling shortly to get our questions. And it's pretty simple. It calls that initialize. Then it also calls sync questions. We'll get to that in just a second. And then it says table, that's our table, .toListAsync. Now remember, when I call table here and then toListAsync, right, I'm actually creating a query, a very, very short query when we look at table here. And then calling toList is my collection method to execute it. Now, interestingly, because I'm doing the whole synchronization thing, right now I'm actually hitting the local table though, because this is a sync table. All right, to make sure that the local table actually has the data that we need, we call sync before we actually grab the data. And it's sync that's going to make sure our local table is up to date. And here we see we first push any local changes we've already got, and then we pull from our quiz table, our quiz questions table. Now here, this is just a moniker for our query. Our query is all, right? We have no wheres or anything on there, where clauses or anything. That's all there is to it. So pretty straightforward. Now I can go back over and we can say that var questions, give myself a little white space there, var questions should equal a new Azure service. Actually, let's just put that on a different line because we are going to be using that again in just a second. Equals new Azure service. So Azure service dot get questions. So we're now getting the questions. However, that should be questions. However, remember, we don't actually have any data in our table yet. So that's kind of a problem. And let me actually do, let's see, what are we returning here? We want to await that. Righto. Await that. So that's going to be then an async on start. So we are now getting the data, but there is no data to get, right? If we recall, our Azure table is still completely empty. We defined it, but we didn't give it any data. So what I'm actually going to do now is modify things just a little bit so that we can still read that JSON file we have and use that as a default to seed the data in our database. Now, of course, this isn't a great idea to distribute to the world. This is kind of just a demo thing. Our world, everyone who downloads this app can go ahead and pull from Azure. But if everybody was looking to just update this set of questions the way I'm about to do, then we'd probably wind up in some race conditions or have a lot of duplicate copies of the same questions. But it does get us some data seeded in there, and it serves to illustrate that we can do updates as well. So for now, we're going to do it that way. Okay, now if we're going to be doing inserts and updates, the first thing we're going to need to do is make sure that our ID field is mapped. Remember, the ID field on the server was automatically created. We just need to make sure that on our DTO side, right, on our side here of our mobile app, that it's actually mapped. So all we have to do is public string actually ID. And that'll take care of it because that is the name of it by default. Now the next part gets a little bit crazier. We're going to go into our Azure service and we're going to model after the get questions. We're going to create an insert questions. So let's do a public, this is an insert, so the return will be void, but it will be an async task actually, so it'll be an async task, not a void. So async task, and it will be insert questions, and the questions will be accepted as a list of quiz questions. With that, we will now, let's see, it's probably telling us there's no await in there. Right, great. All right, so we'll first await initialize. And again, this is just to make sure everything's initialized. Remember, initialize won't run if it's already been initialized, so we just always want to make sure. Now, we're going to be inserting and then want things updated on the server side. So the last thing we're going to do is update the server. So we can actually give ourselves a little white space and call sync questions here. Okay, now let's actually do the meat and potatoes of this. What we want to do is we want to take each one of these questions that comes in, right? So I want to do, for each question, I actually want to generate a task because we know insert is a async operation, right? So we're actually going to use select here. And I will say for each question, I actually need to get the link using in there. There we go. Okay, so now we can actually do this properly. For each question, I'm actually going to do table.insert async and insert the question. So once I have all those going through, now I've got a whole bunch of tasks actually executing, one for each of the questions. But I don't want sync to happen until all of these are actually done, right? So what I'm going to actually do then is take the entire questions.select, the entire set of tasks that this generated for me, and I'm going to await all of them. So let's do await task.whenAll. There we go. So when all of these are complete, then my await will say, all right, this task represented by the whenAll will allow us to move on to sync questions. So we generate a task for each insert, we wait for all of them, and then we go on to sync questions. And now we'll have our database populated, our remote database populated with whatever came in here. So that's how we're going to get our remote and local databases populated. But where does this list of questions come from? Well, that part's actually pretty easy because we're going to go back to our app, and the stuff that I commented out earlier is actually going to be exactly what we're going to use to populate our data. So let's say that after we've gotten questions the first time, if questions.count is less than 1. Actually, we have a better way of doing that, don't we? Questions.any, we just need our link statement in place. There we go, our link using in place. If not questions.any, then we will grab all of this and we'll allow that to take over. Uncomment the code. Get some extra white space in there. And now this one shouldn't be var anymore because it's just populating the variable that we already created. Okay, so now that's my questions. So now I don't want to go through this every time though, right? I say, all right, if my Azure questions do not return as I expect, right, then I'm going to pull it out of the JSON file that's stored locally, that's stored in my mobile app here. And then what I want to do is never have to go through this again. So we will grab Azure Service here again and say insert questions, passing my set of questions. And then that should execute the code that we just wrote. Now this of course is an async, and we do actually want it to wait until this is all done. So we will do await. Oh, and move it to the correct spot. Hold on, we are not anywhere near the correct spot. Well, we're near the correct spot. We're not in the correct spot. Our insert should actually be inside the if, shouldn't it? There we go. Otherwise, we're going to be inserting a lot of duplicates. Okay, now we've got it in the right spot. And we actually need to go back here. You know what? We didn't ever get to updating this, did we? Let's go and update, make sure we're pointing at our correct database or our correct Azure mobile app here. Actually, you know what we can do is go all the way up here to the overview and copy. That'll make sure we get it exactly right. Back, and boom, boom. Paste that in place. All right, now set Android as our startup project. Let's see everything come together, shall we? Let it build. Well, that does its thing. Let's go back here one more time. I want to show you guys that after we added the easy tables, right, it actually did add those here in my tables subfolder. Right, we've now got a quiz question.js, a quiz question.json. We've got some settings for the table right here. Technically the JS, you could actually set the settings there just procedurally, but also more importantly, what the JS file allows me to do is add middleware or add middleware functions that allow me to intercept insert calls, update calls, read calls, to allow me to add custom business logic to whatever's happening to my tables. All right, so again, actually have direct access to all the code. Even though it's auto-generated, it's still our code. It's still code, not magic configuration that we can't touch. All right, let's go back. We should be built by now, and we are. And hit start. And we'll just give one answer, and then now we're going to go back and just see, do we have any data? And we should. We saw that we got a question. That, of course, came from the JSON, but we should have at the same time updated our table. So go find my easy tables section again. Hit that quiz question. And our results say, all right, we have records. Excellent. We can even, let's actually do something here. We're going to go through and we'll delete several records just to show that we'll only have 2 when we run it again. So if I delete a few records here, we'll want a soft delete. And once we see that update reflected, and there we go, we have it, we can go ahead and double check to make sure that we only have 2 records showing up on our app. By the way, the reason we use soft delete is because we want to make sure that those changes, that setting change, that value change does get synced back to our client side. All right, so back we go over to our app. Let's give it a restart just to make sure we have the latest and greatest. All right, just about there. Give me my button. There's my button. Start exam. Xamarin Forms is a great choice when you're required to follow pixel-perfect mockups. No. Next, when developing an app using Xamarin Forms, the applications will look identical. False. And let's see. Yes, only 2 questions. All right, perfect. That is fantastic. One other thing we can do to check that everything is working exactly like we expect, we could come over here and completely get rid of our offline stuff, get rid of that JSON stuff so that we're only using our Azure service to get questions, right? Only using that. Let's once again comment all this out. Now that our data has been preloaded, right? Now what I'm going to do, I'm going to put my emulator into offline mode, into airplane mode. And now it can't get any data from the internet. No data at all. Now we're also not able to load it up from JSON. So this is going to prove that it's successfully loading it from our local database. And give us a run again. And let's hit our button one more time. And we still have our questions. Excellent, even though we're in offline mode, as we can see. All right, that's about it. So what have we learned today? We've learned how to set up a backend in Azure for our mobile app. And we learned how to access that backend from our mobile app using the libraries available to us. Finally, we learned that we don't even have to choose between online mode and offline access. We can have the best of both worlds. We can synchronize when we're online, but then always have access to our data even when we're offline, even the ability to update and insert when offline. Guys, as a reminder, everything that we are seeing today is brought to you by Xamarin University. All of us instructors that are teaching you right now, we are Xamarin University instructors. We're going really fast. We're only touching the surface today. We have much, much deeper materials. And if you want to continue getting a sample of what's available at Xamarin University and even have that sample apply towards certification, check out the self-guided learning we have available for free at university.xamarin.com. All right, next up is going to be our UI testing and analytics. Guys, it's been a great, great time having this session with you today. I hope you enjoyed it as well. Thank you very much. Goodbye for now.